Hi everybody! So far in this chapter we've been learning about systems of equations and how to solve them. We've looked at solving them by graphing, we've looked at solving them using substitution, and solving them using elimination. Today what we're going to do is we're going to look at how we can use systems of equations in modeling problems. So anytime that we've had a modeling problem, we've said it's called a modeling problem because it represents a real world situation. So what we're going to do today is look at some word problems or real world situations and try to come up with equations to represent them that we could then solve. So when we are modeling a real world situation, sometimes we need more than one equation in order to solve it and represent the problem. When you're trying to set up these problems, there are a couple steps that we can follow to make our lives a little bit easier. So the first step would be to identify our variables. Now, you're going to need the same number of equations as variables. So if when you read the problem you realize there are two pieces of missing information, you're going to need two equations to solve that problem. If there's only one piece of missing information, you're only going to need one equation to solve that problem. Then you're going to write the appropriate number of equations. For now, you're usually going to need two of them. And finally, you're going to solve the system using either substitution or elimination, which we've been practicing for a couple days now, so we kind of know how to do those things. By the time you get to step 3, you should kind of know what to do because we've already practiced step 3. So let's read through a couple problems, practice identifying the variables, setting up some equations, and then solving. So problem number 1 says, the school that Jacob goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 4 senior citizen tickets and 12 child tickets for a total of $140. The school took in $100 on the second day by selling 8 senior citizen tickets and 6 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. When I read the last sentence here, which is really the question, I can identify two pieces of missing information. I want to know the price of a senior citizen ticket, and I want to know the price of a child ticket. So step 1 is going to be to say, okay, I'm going to let S equal the price of a senior citizen ticket, and I'm going to let C equal the price of a child ticket. Now it's really important that we know what our variables stand for, because once we've identified that there are two missing pieces of information, that's how we know we're going to need two equations. So step number 2 here is going to be to write two different equations that will help us solve this problem. If you have two variables, you must have two equations. So if I read through the problem again, each sentence in this problem is basically setting up one equation. So for example, 4 senior citizen tickets and 12 child tickets for a total of $140. So what I can do is I can set up an equation where I have 4S, because there were 4 senior citizen tickets, plus 12C, because there were 12 child tickets, for a total of, which means equals, $140. Now the next sentence in this word problem is a second equation. The school took in $100 on the second day by selling 8 senior citizen tickets and 6 child tickets. So again, 8S, because we sold 8 senior citizen tickets, plus 6 child tickets, so 6C, equals a total of $100. Now, after you have two equations written and you know what your variables stand for, you're going to solve this problem using either substitution or elimination. Because of the way the problem is set up here, where the S's are lined up, the C's are lined up, the equals are lined up, and the numbers are lined up, I'm going to use elimination. So in order to get one of the variables to eliminate, I'm going to multiply the first equation by -2, because that will turn my 4 into a -8 by the S, and the S's will cancel. So I'm going to have -8S minus 24C equals -280. And the second equation is going to be 8S plus 6C equals 100. Now, the S's will cancel. So -24 plus 6 is -18C equals -280 plus 100 is -180. And then to solve that, I would just divide by -18. So C equals 10. And because C was the price of a child ticket, I can say that was $10. Now, just like always, I'm not quite done yet. I still need to go back and figure out what S would be worth. So I'm going to take my C. I don't know where to write this. I kind of ran out of room. I'm going to take my C and I'm going to plug it into one of these equations and I'm going to find S. So 4S plus 12 times 10 equals 140. 12 times 10 is 120. When I subtract 120, I get 4S equals 20. So S must be 5. And since S is the price of a senior citizen ticket, $5 would be the value of S. Okay, let's go ahead and try number 2. It says Jack and Betty have 28 coins that are nickels and dimes. If the value of the coins is $1.95, how many coins of each type do they have? So since it says how many coins of each type, and I know we're talking about nickels and dimes, I know that I'm going to let N be the number of nickels because I want to know how many. And I'm going to let D be the number of dimes. Now, unlike the previous problem where each sentence was basically an equation, in this problem, well, kind of like the previous problem, each sentence is an equation, but it's a little harder to figure out the equations because it doesn't say like 5 nickels plus 10 dimes. It just says we have 28 coins. So equation number 1 is just going to say that if I take the N plus the D, I get 28 because if I add up the number of nickels plus the number of dimes, I have 28 of them. Now the second equation says the value of the coins is $1.95. Now value means nickels have a value. They're worth 5 cents. Dimes have a value. They're worth 10 cents. So I can't just say N plus D is $1.95 because the nickels are worth a different amount than the dimes. So I would have to incorporate here the value of the coins, like how much they're worth. So instead of just N, I would say 5N because each nickel is worth 5 cents. Plus, instead of just D, I would say 10D because each dime is worth 10 cents. And then 1.95, but I'm not going to write 1.95 because since this is 5 cents and this is 10 cents, I need to convert this to cents. So it would be 195 cents. Now what I'm going to do is solve using either substitution or elimination in this problem because the N's are lined up and the D's are lined up and the equals are lined up and the numbers are lined up and everything is lined up. I'm going to multiply the first equation by -5 and I'm going to use elimination. And the reason I'm choosing to multiply by -5 to the first equation is because that's going to make the N's cancel. So I get -5n minus 5d equals -140. And then I have 5n plus 10d equals 195, which means the n's are going to cancel. and I'm going to get 5D equals 55. And then if I divide by 5, I get D is 11, and D is the number of dimes, so 11 dimes. Now what I'm going to do is just take that number and plug it back into one of the original equations to figure out how many nickels I have. So if I plug that number back into the first equation, I have n plus 11 equals 28. And then if I subtract 11, I get n equals 17 nickels. Okay, let's look at one more problem, and then I think we're kind of done, or two more problems, and then I think we're kind of done with these notes, and we'll practice this tomorrow. So, Six Flags is a popular field trip destination. This year, the senior class at Maine East and the senior class at Maine West both planned trips there. The senior class at Maine East rented and filled 14 vans and one bus with 166 students. Maine West rented and filled 7 vans and 14 buses with 434 students. Every van had the same number of students in it, as did the buses. Find the number of students in each van and each bus. So, it's a little typo, it should be van. Since we want to know the number of students in each van and each bus, my variables are going to be V equals the number of students in a van and I'm going to let B equal the number of students in a bus. Now I'm going to try to set up equations. So again, there are two equations because we have two variables. The first sentence that says here, I filled 14 vans and one bus with 166 students, I would say 14V plus 1B equals 166. The second sentence says I filled 7 vans and 14 buses, so 7V plus 14B with 434 students equals 434. I would solve this with elimination because everything's kind of lined up nicely for me. So I would multiply this time the bottom equation by -2, and the reason I'm choosing to do that is that will make the v's cancel. So I would have 14v plus 1b equals 166, negative 14v minus 28b equals negative 868. The v's are going to cancel, so I get negative 27b equals, I'm going to go ahead and see, it's negative 702, I believe. And then when I divide by negative 27, and I'm going to go ahead and use my calculator for that, I don't want to make a mistake. I get 26 students fit on a bus. Now, in order to figure out how many students fit in a van, I'm going to take that number and I'm going to plug it back into one of the original equations. So I'm going to have 14v plus 1 times 26 equals 166. So 14v plus 26 equals 166, which means 14v equals 140, so v equals 10 students in a van. One last problem, and then we're good to go. It says the sum of two numbers is 24. The difference of the same two numbers is 4. Find the two numbers. So here we're trying to find two numbers. It doesn't say there are any specific kinds of numbers. So for these types of problems, I would just call them x and y. So x equals number 1, and y equals number 2. We're trying to find two numbers. Now it says the first sentence, the sum of two numbers is 24. Now the word sum means add them up. So I know that if I take my number 1 and my number 2, and I add them together, I get 24. The same two numbers, the difference is 4. So I know if I take those same two numbers and I subtract, I get 4. Step number 3 is going to be to solve. Now to solve this, I don't really need to do anything extra because the y's will already cancel for me. So I have 2x equals 28. And then if I divide, I get x is 14. That's number 1. And now I'm going to take that number and plug it in and try to figure out my y. So I'm going to plug it back into my original equation. 14 plus y equals 24. So y equals 10 would be number 2. Okay, thank you guys so much for watching. I know this is a little bit of a longer video. I'm hoping it made sense. We're going to practice these word problems tomorrow, and I will see you then. Have a great afternoon.